Okay, question 36. We're having a look at fuel cells. So it says fuel cells provide a much more efficient process, often with a 70% conversion factor. State the energy change conversion involved in a fuel cell. So if we remember, a fuel cell is a type of galvanic cell in which we are converting chemical energy directly to electrical energy. And that's why the efficiency is a lot higher than with our coal-fired power station. Question BI, identify the two half equations that take place at the positive electrode, the cathode, and the negative electrode, the anode, in a hydrogen-oxygen fuel cell with an alkaline electrolyte. So when we're writing our half equations, so our half equations are showing our reduction and our oxidation, and we are including the loss or the gain of electrons. We need to make sure that we're having a look to see what conditions the fuel cell is under. So this is an alkaline electrolyte. Okay, so in an alkaline electrolyte, we have hydroxide ions. I've just popped this diagram in here to help demonstrate it. Hydroxide ions, we don't have hydrogen ions. This makes a difference in our half equations, but the overall equation for alkaline conditions and acidic conditions is the same. So if we have a look, this is straight from your data booklet. If we have a look here, if we had it under acidic conditions, we'd have oxygen producing or being reduced and forming our hydrogen ions. But what's happening is because it's under alkaline conditions, we want hydroxide ions forming. Okay, so that's a reaction that's going to occur at our positive electrode, our cathode. So here we've got our oxygen coming in. That will, let's just do this here. Okay, so at our cathode, let's cut and paste this, makes it easier for me. So we've got our cathode, so that's our reduction occurring. Okay, so our oxygen is reacting with the water, it's gaining the 4 electrons, producing 4 hydroxide because it's under alkaline conditions. Now we've got the other half equation to do, which is our oxidation. So we have got, why is it not moving over forward? Okay, so at our anode, we have got, what's my pointer called? Okay, we've got our hydrogen coming in. Remember, these electrodes will only allow certain species to come through. Okay, they're making sure that there's no direct contact between the reducing agent and the oxidizing agent. And in the middle, we've got our electrolyte. In this case, it's our hydroxyl ions. Now, the hydroxyl can only, because it's an anion, will migrate towards the anode. So what happens is our hydrogen gas will lose 2 electrons, forming hydrogen ions. Okay, those electrons can't pass through the electrode. They are forced to travel along through the wire from the anode to the cathode, and that's our current. So that's what's occurring. Then over at our cathode, those oxygen are gaining those electrons and forming the hydroxide ions. Then those hydroxide ions will react with our hydrogen ions to form our water. Okay, so over at our anode, we'll have, let me make it balanced, 2 hydrogen ions reacting with hydroxide ions. Okay, and that is going to form water. Okay, now this isn't a redox reaction, okay, because if we look here, we've got 2 positive plus 2 negative, that's neutral, and water is neutral, okay. So this here is our oxidation reaction, forming our hydrogen ions. It's reacting with our hydroxyl ions to form our 2 water, okay, my species 2, okay, and that's what's occurring over at the anode. But it wants the overall anode equation. So what we can do is we can cancel out some things. Okay, so our hydrogen ions will cancel out, which will give us an overall reaction at the anode of H2 gas plus 2OH minus aqueous. okay, plus to give us 2H2O plus 2 electrons. I can't write very well with this, okay? And that's what's occurring at the anode, okay? So this would be our answer or our half equation for the anode. BII, it wants us to state the overall reaction identifying the states of all species involved. Okay, so one way of coming over with the overall reaction is to add your cathode and your anode reactions together. You're cancelling anything that is the same. Okay, so if we write out our equations, over at the cathode we had 2 plus 2H. I really can't write very well with this. Okay, 2H2. What I will do. 2 seconds. Okay, discard that. We'll put in a textbooks because this will be nice. Okay, so there we go. Done. So I've got our two half equations. This was our answer to VI. If I cancel out what is the same, I get my overall reaction. But before we do that, remember when we were balancing our redox reactions? We need to make sure the equations are the same number. So I've got 4 electrons and 2 electrons. So if I double this, we will have 4 electrons in here. So let's double this first. Okay, got a bit going on. I've got the chickens going. I've got my neighbor doing his personal training next door and the children. Okay. H2O, I haven't included states, plus, okay, 4 electrons. Okay, so those half equations, the electrons are balanced. Then I can take this one and my oxidation and to get my overall. So I've got, where have I got? So I've got 4 electrons, cancel out 4 electrons. I've got, where else? 4 hydroxide. 4 hydroxide, I've got 2 water there, 4 there, so that become 2. Okay, and then I just take what's left. So then overall I would have 2 hydrogen with gas. I can't write very well with this, and that chicken is very loud. Plus oxygen gas gives me 2 waters. Okay, and that's my overall reaction. Okay. So, last question, or second last. Outline the function of the thin polymer membrane used in the corresponding hydrogen oxygen fuel cell with an acidic electrolyte. Okay, so this time it's under an acidic electrolyte. That thin membrane allows the flow of the hydrogen ions through. Okay, so it's allowing just your hydrogen ions through so that it can move across, okay, from the electrode into the electrolyte. It won't allow the electrons through, okay, because then that forces the electrons to go up through the wire from the anode to the cathode. The last question was outline, other than cost, state one disadvantage of a fuel cell. So if we remember in our experiments in class when we were making our galvanic cells, after a while the reaction will stop occurring because we have used up all the reactants. So a fuel cell will need a constant supply. So when we were looking in class at the hydrogen fuel cells and we were looking at the example of the electric bikes, we know that they had the hydrogen canister, which was supplying constant supply of hydrogen gas, but that would need replacing. So that would be one disadvantage other than cost to a fuel cell.